Alright, so let's say you're given this diagram with these two coefficients for friction, and they ask you, if I apply 5 newtons of force on the object, but it does not move, where's the force of friction? Also, where's the force of friction if it does move? Would you know how to solve? If not, continue watching this video. So we can start off by identifying that we need to know two key concepts to solve. What is the kinetic friction and what is static friction? To understand the difference between these two, let's imagine an example where you're trying to push a heavy box. So I'm trying to push this heavy box here. When you try to get the box to move, why does that rest? There's a force of friction that will oppose this force. So if I draw a free body diagram here with the force applied, there's also a force of friction that will oppose this force. This force of friction while the object's at rest corresponds to the static friction, given by this equation here, which is Fs is less than or equal to Fs max is equal to mu Sn, where Fs is just means the static friction, where Fs max is the maximum static friction. This is the maximum amount of force just before the mass will start to move. Us is the coefficient of static friction, and N is just the normal force. Now let's say that we push it enough for it to start to move. This diagram below just shows the box actually moving, and we can label two friction forces, FF2 and FF1. So in this example, FF2 will be smaller than FF1, and this is due to the momentum. Once an object is pushed into motion, it's easier to push it and keep it moving in motion, if you ever noticed that in real life. The friction while the object is moving is called the kinetic friction, and it's given by this equation here, where Fk is equal to mu Kn, where Fk is just the kinetic friction, mu K is the coefficient of kinetic friction, and N is just the normal. With these two definitions, we now apply back to our example. If we solve for the kinetic friction first, this is if the object is moving, we can use our kinetic friction equation. Notice our coefficient of kinetic friction is 0.3, so we plug that in. And then the normal force is equal to mass times gravity, so we can replace that, plug in our known values, and we get this for the final answer. This is the force of friction if the applied force caused the mass to start moving. However, since in this example, our applied force is only 5 newtons, it most likely wouldn't have got it to move because it's so much less than the force of kinetic friction. Additionally, we can look at the static friction. So if we use our static friction equation, the static friction is going to be less than or equal to the maximum friction. So we can calculate the maximum friction possible by first plugging in our known values, and we get this expression here. We can do just a simple multiplication and get this for the final answer. So this is going to be the maximum amount of friction before the object starts to move. However, this is not the force of friction that we are looking for in the question. From the force applied being 5 newtons, to find that, we would have to use Newton's second law, and I'll let you guys try to do that yourself. I can also do an additional video showing that. I just wanted to show how to find the maximum amount of friction before the object starts to move. And if we compare our static friction to our kinetic friction, we can notice that the kinetic friction is much less than the static friction, and this makes sense because we just said previously that pushing an object that's at rest is going to be harder than pushing an object that's already in motion.